Well, good morning, everybody. I'm going to start off today by talking about kind of where this pattern has gotten us, because I do think we're going to see a bit of a shift in it here in the next 7 days, and therefore we need to understand what this pattern did and why the shift could be significant. I also want to tell you that there's a pretty big failure mode in this upcoming pattern shift that should it not shift around, we're going to continue on with this pattern we've been seeing, and there is some opportunity in the atmosphere for that to occur. So this is the latest soil moisture map from NASA. It goes down to 100 centimeters. And again, it's a percentile, so this is looking back and almost giving you a rank. And what we need to just remember here is that this spring precipitation pattern has undone last fall's drought for a lot of people throughout the United States. Now, I'm specifically thinking about the Mississippi Valley, parts of the Ohio Valley, and Missouri Valley. That is an area that when you went into last fall and throughout most of winter, there was no major recovery of soil moisture. But given how wet things have been as of late, this entire region has seen significant improvements. Again, as I normally say, this is not to ignore places that have not received this precipitation or the drought kind of busting precipitation, but I have a feeling when we get tomorrow morning's new drought monitor, we'll see more class improvement across the country given how active this pattern has been as of late. I do want to show you currently where our rivers that are currently showing action through all the flood stages. And as you see the next couple of maps, which kind of highlight where this heavy precipitation has been, this will make a lot of sense. Just so you know, the shading that they have in the background here, this just represents where there are currently flood watches this morning. And this is going to be an active area over which we're going to be paying close attention to severe weather later on this afternoon as well. Coming right down here to the Mississippi River, let's take a look at the individual gauge there at the Mississippi. So currently it's sitting somewhere around 18 feet above low stage. Again, that drought last fall is right in through here that lasted all winter throughout much of the Mississippi Valley. I also want to take you out west briefly. I mentioned some snow that happened in the west over the weekend. There's still snow going in the Rocky Mountains and some places in Montana today. And we have a frost and freeze warning out for even the high plains of Colorado as they butt up against the Rocky Mountains. But this is just a quick look at snow water equivalent as of May 7th. Now, I know this isn't a map we normally look at in May, but it just shows you how much snow is there compared to the historical averages. And just for context, remember last winter it looked something like this going into May 7th. So a little different scenario with the snowpack. Still great snowpack this year for a lot of the West. Not everywhere, but a lot of the West. But to compare it to a year ago is kind of unfair given just how much snow we had last year. Okay, so what got us there? And I'm going to come back to this again at the very end, and I do have some new long-range trend data for you in both the European model and in the NMME, which was just released. So what I'm going to be focusing a lot on over the next several weeks is this guy right here. So we've had for a while high pressure that's kind of extended in this area. And this is April 1st through May the 4th. Now what that high pressure cell has done is that's basically, in a nutshell, pushed the atmosphere up a bit here. And we've now seen the flow dip south, I should say north, not up, but dip south through the Gulf of Alaska. It's kind of entered the country something like this. About the only thing that could have made the midsection of the country, where we've seen such huge severe weather events and incredibly heavy rainfall, what could have only made that worse is if we would have planted a big high pressure cell permanently over the southeast. That would have sent the southeast into drought, but it would have pushed even more moisture into the midsection of the country. And honestly, that's the major difference between this year and 2019, that particular spring. Now, the reason why I bring this up is because of where I think this high pressure cell will be once we get past the middle of this month or toward the middle of this month and beyond. Some of the models are bringing it here. And just to make a point about why I think this is so important, if we get into late May and early June, and that high pressure cell moves towards British Columbia or Washington or Oregon or Northern California and stays, we get into the scenario, that low probability scenario that I discussed last week, that says we may be talking about western U.S. ridging issues. And that's going to be really critical to the upcoming growing season for the rest of the country and the fire risk season for the West. So this is going to be kind of an important topic for me until I have evidence to overturn it, or whether we see it's there or not, because what it's done to the atmosphere is this. These are anomalous winds at the jet stream level. So again, compared to average, so you can see the effect of that flow doing something like this. Now, this does not mean the winds have gone backwards here. This is anomalies. It's just showing you that their component, the anomalous component, is out of the east. But what it's done is it's allowed the subtropical jet to kind of roll right in through here. And what you've seen this do is draw dry conditions out of Mexico, pushing them through western Texas, out of parts of New Mexico into Kansas. And then all around the periphery of this, we've just seen a tremendous amount of severe weather. So that has been the pattern that we've been in. And we're going to look for that pattern to possibly shift or move. That's what we have to see happen here. Okay, thinking all of that through, let's look at the last 30 days as a percent of normal. So again, this is the result. And you notice that there is much more area across the country that has had a normal to wetter than normal spring. Some places extremely wet. I'm thinking about this whole region down here in Texas that's had somewhere between 600 in some places nearly 1,000% of normal precipitation over the last month. Our drier areas lately have been getting some better moisture. We saw some moisture getting into Kansas. We've seen some of the really dry conditions that have been here in North Carolina, Virginia, getting knocked out recently by some storms. And we still have pockets, there's no doubt about it, that have been drier, like the Columbia Basin, just as an example. But this pattern has been one that has been largely a drought-correcting pattern, save a few different areas. Now, as we look at it, I want to show you just the last 72 hours, because we've had, of course, this multi-day severe weather outbreak, which is going to continue again today. And what's impressive to me about this is, of course, all of the severe weather, but take a look at the wraparound on the back side of this and the upslope flow that we've had just rolling across Montana from east to west, just continually gaining elevation, helping the air to rise, just delivering a lot of precipitation, a whole lot of precipitation. And we're going to watch this system continue to evolve today, but yesterday, just have a look at this. This was on satellite yesterday. The upper level low spinning over the Dakotas, the back side of it through southern Canada, up against Alberta, pushing into Montana, and snow squalls throughout the Rocky Mountains, all enhanced by the mountains, of course. We saw this very fascinating cloud feature deep in the atmosphere that was just showing the speed at which the jet stream is curling underneath this. And then, of course, it was that wind shear that provided what was needed to produce the severe storms that ripped off into this area right in through here yesterday. Now, that's not to ignore the big storm. Watch this one that popped up right here in Tennessee. That was a monstrous storm here. And then take a look at the size of the storms that were rolling through parts of North Carolina as well. But just thinking back through this, I'm going to show you the last 2 days of tornado reports. So more have been filtering in. We're up to 471 total reports, 30 tornadoes. This was from the high-risk day on May the 6th. And then yesterday on May the 7th, just have a close look here, another 246 reports of severe storms, including another 26 tornadoes. Remember, when you go to the SPC webpage and you look at the storm reports, you actually have access to all of the reporting data here. And I'd like to show you one of these tornadoes because it was sent to me, and it's this one right here. It was reported near the town of Milroy in Indiana, but we have a Nutrien Ag Solutions facility very close to there, and I had pictures and videos sent to me. So before I get to that, take a look. These storms contained a lot of hail in them as well. And just to look at some of these hail reports just from the last 24 hours here, some of this was getting up to be, we had some stones right in through here they were very oddly shaped. I hope the National Weather Service will share those with us, but very oddly shaped but large hail. But I mentioned the tornado, so let me play this one for you. This comes from Joel Griffin, but the video was sent to me by Danny Carmody. Fantastic group of guys there in Indiana, just an outstanding division for us. But just take a look at this. Now, this is amazing. You have dirt and dust at the bottom, but condensation at the top. And there is circulation here, just so you know. But unless the tornado has dirt, debris, dust in it, or condensation, you won't see it. And what was more interesting to me about this particular storm, and I understand there was some damage from this, but what was more interesting, if we just watch it one more time, was where it is with respect to the rest of the storm system. Because you notice it's incredibly visible. You can see very clearly around it, no heavy rainfall. And I thought it'd be kind of neat just to show you what this one looked like on radar. So here we are. This is using the Indianapolis radar, which is here. And the storm we're going to be talking about is right there. Many of you probably already can see that this one had a very well-defined hook echo on its southwest side. We're going to focus in on that in a minute. But I thought you might find this interesting. If you kind of zoom in here on the Indianapolis radar before we even look at that storm, It's neat to see this radar because you can actually see with the radar, see these echoes that line up right here with the blue line? This is, of course, picking up here on, what is this? This is 74? I got to back this up. No, I'm sorry. That's 70. Highway 70, or Interstate 70. It's actually picking up on the traffic. So the echoes, once the rain gets by, those bright echoes there. In fact, there's a better example right here. Now, I don't remember. I go to Indy quite a bit. My sister lives there. But this must be, right in through here, a spot where the highway comes up a bit. Must be higher elevation just right there because we get echoes off of that all the time. Just a fascinating thing. Now, let's come back to the storm. Here is the storm we're talking about, and you're going to see, watch this restart. Here it is at the end. It's going to come right back there. Now, let's pause this just for a second. I'm going to take you back through it and just show you some of the amazing components of this storm. Now, pretty well-defined hook echo right in through here. In fact, let's just go back a couple more steps. Yeah, very well-defined hook echo. This is called the rear flank. So this storm actually has all the way through here a downdraft that comes around the back side like this. Sorry, I'm drawing in black over black, but here's the main updraft. In fact, if I switch this over to velocity, okay, now I got to take you back to that time so that it's consistent. Let's get this playing here. You'll actually be able to see the velocity couplet that was observed during this storm. So hopefully this will play for me here. But you can already see it. This is where it ended up. You see the differences in the colors, the greens and reds. The greens and reds, these are two different rotating storms in this area. And I apologize. Oh, there it goes. Let's pause it right there. Now, if you take this storm back, this is the guy we're watching. That's as it went right over Milroy. Can you see the red-green velocity couplet in there? That is where the storm's rotation was being basically seen by the radar. And I always just find this amazing and fascinating to look at. But I just wanted to share that with you, this one particular storm here on radar. Okay, let's get back to it. Let's blow this up so it takes up the whole screen and get on to the next bit. This morning, just before 6 a.m., this is what our all hazards weather map looked like. We're still dealing with very strong winds coming out of Montana. This is winter storm watches and warnings and advisories. This is a freeze watch and freeze warning out for parts of Colorado, and red flag warnings farther to the south. Freeze warnings still dot parts of Utah, getting here into northern California, southwest Oregon, and the rest of this is frost advisory in through this area. So I guess I should say frost advisories. Yeah, that's a frost advisory color, including this. Flood watches remain here, and we're going to keep a close eye on this area for severe storms later today because the setup is just about ideal. As this resets, take a look at the low-level wind field. So you have the dry air coming out like this, curling around this low. The very moist air coming up from the south, here's the high-pressure cell that's helping feed it. There's a bit of an inflection point right here in the atmosphere, a little saddle in the flow, which is going to be the boundary on which these storms form. So they're going to form to the south of it, right into this part of the MidSouth and Ohio Valley. But on the back side, the upper level low is still stacked over here, which is why we continue to bring that upslope flow. See it right there hitting the Rocky Mountains. And then coming off the mountains here, some stronger winds. So this is just a fascinating system to try to diagnose. After it, watch that guy right there. That's high pressure. It's trying to build into British Columbia, the Pacific Northwest, and change this pattern up. And we'll just need to see how long it's going to last. So today's storm predictions here, let's see if we get an update on this. There we go. The Storm Prediction Center's outlook for severe weather, broad area of enhanced risk, but they've identified this part of Missouri getting into Kentucky, Tennessee as having a moderate risk today. So we need to keep a close eye out there, and we'll see what the radars are showing in a few moments. The day 2 forecast, this front finally sags farther to the east and south. We have an enhanced risk in this part of Texas on the back side of that frontal boundary. And finally, by day 3, it's so great just to see a marginal risk of severe weather. Really great to see that. I'm ready to move on from this pattern. It's produced so much damage and destruction. I would just like to see something shift with it. All right, so this morning, looking at some live lightning data here. This is, again, just before 7 o'clock. We've got storms that are coming just near Kansas City, but then lining up right here on the border between Kentucky and Tennessee, some down here in Arkansas as well, and some lightning and thunder with some storms that are still in parts of the Northeast too. I want to show you a couple of different model runs. Let's pick this up at 7 a.m. I think this was a good initialization from the high-resolution rapid refresh. We can see those complexes of storms pretty clearly. So as we play through the middle of the day, we're going to watch that boundary sitting right there by mid-afternoon for the risk of some stronger storms to begin to show up. Now, the wind shear along this boundary is what's going to be unique about it, and it'll be important to watch initial storm type before it appears that a broader squall line of thunderstorms rolls through. So where are we in time? This is 6 o'clock this evening, getting to about sunset through the night, and you can just see a large complex of storms expected to roll through that area. We have rain farther to the north, we have the wraparound on the backside, and the high-resolution rapid refresh model only runs out 36 hours. And so we'll just see where this ends up by the time we get to midday Thursday, which is what you've got here, including what could be the remnants of today's storms getting into the southeast. Now, since it only goes out to 1 o'clock on Thursday, let's flip over and look at the high-res NAM, which goes out 60 hours rather than 36. And I always color code this one for precipitation type as well. Once we get out of the risk of snow, I'll just show you the radar, a simulated radar from it as we go into the rest of summer. So here we play again. Very similar setup. Again, you can see that same complex of storms rolling through this area, lining itself out by the time we get into the overnight hours tonight. Into tomorrow, we'll watch for what's left of that getting down here, riding along this boundary as widespread rain moves from parts of eastern Iowa clear to Pennsylvania. The upper level low is starting to flatten as the ridge builds in north of it, which is going to take that out of commission from parts of Montana and Wyoming. But take a look at Colorado here. Snow is going to be certainly falling in this area. As I play this out through midday Friday, that's when that front finally sags its way toward the east coast and toward the south, and we start to just get a different look at everything. Now, you saw a lot of blue in through there, and I just want to show you, this is the probability of grabbing a couple inches of snow over the next 72 hours. So just be aware that into the mountains, we've got more snow coming from this. All right, the pattern. This is where I began today. This is where we're going to keep this thread going. If you look right now, this ridge, to me, is the most important component of this pattern. Because as we move forward, that ridge builds into British Columbia and gives us this high over low setup, which is going to leave a lingering trough here. Now, yesterday, I really went after that trough, and I want to show you the evolution of it in the European ensemble. So you can see that the deeper lows move into the east by the end of this weekend, and this is going to be the cool down that's going to follow. Thankfully, I'm not worried about a big frost coming in way down far to the south. Up here in the UP into Wisconsin, sure. Into parts of Ontario and Quebec, yes, that would not be unseasonal there. But I don't see this dropping significant cold air down to a frost. But we're going to have some days where highs are in the 60s because of this. Now, where are we? This is Saturday, getting into Sunday. And the models continue to kind of give us this look. See it with broader troughs here. But look what comes back. More ridging that had been way over here north of Hawaii. And as we display this forward into Tuesday and Wednesday, I continue to see the pattern kind of evolving in a different way. See these troughs here? They're not coming out of the mountains. They're developing farther to the east, which is going to give us a whole different look on precipitation. And what this will likely do is curl systems up farther to the east as we play past the middle of this month. I'm at the 17th here. And just going out there a bit farther, we do see that the pattern, I know it's 300 hours from now, but this is May 20th. I don't see that checkmark style that we had so long, right? I see shifting around of ridges. I see more zonal flow in the pattern. Now, it could be because the models have washed out any significant feature, but it's different, right? We had strong signals from late April and through early May. We've been looking at them all the way back to, mid-April, knowing that we could get into this very active time period, and now it's beginning to make a bit of a turn here. So what does all that mean? Well, let's just look at the next 7 days first. I think the artificial intelligence is back up and going. ECMWF sent me an email yesterday saying how they've been moving some stuff around. That's good. But this is where we're looking at the best chance of getting some moisture over the next 7 days, according to the artificial intelligence. So wet south, wet southeast, wet mid-south toward the Appalachian Mountains and east. Drier signals showing up here. Most of this is now. All right? So what about the WPC? That's their forecast for the next 7 days. And what I'm trying to identify is, do we have some open planting windows returning into this area? This is the update from the NBM, National Blend of Models. Quite similar outlook as the WPC. This is the European. Whoops, I wanted to play the European for you. Because as we get this out here, This is all the way out through Monday of next week. That's played out a full week right there. And so did you notice, like if I just do this fast again, keep an eye on your area. And you're just watching for additional moisture to be coming in, right? So I'm looking here for places that are going to finally start to see some windows opening up. I'm going to do the same thing with the GFS. That's a quick look at a week there. So quite wet across the south as the front lingers, but a lot of places are going to start to get a break. Our probabilities over the next 7 days of getting an inch look like this. Now what's different? Well, there's no longer this widespread area all through here that had high probabilities of getting an inch. We now start to back this off. And if I flip this down to who's going to be on the drier side of things, yep, just got a new model run here. Let's go back to the old 0Z. Take it out here. Let's go out just a week. These are the areas that I'm expecting to see better chances of being on the drier side. So the Dakotas, parts of the Canadian Prairie, getting into the Western Corn Belt. There's a large area in through here that, based upon, where was that map? There you go. We could use some drier weather in this area to kind of get things to slow down a little bit. So from there, here's the one I was on. Let's go look at the models. GFS left, European right. Picking this up tonight. That's the complex of storms we're going to be keeping an eye on here and in through here. It's in both models. Potential for some very heavy rain right into this area. All right, getting into tomorrow. Front sags. Risk of severe storms from Texas all along this boundary. That's tomorrow night on Thursday. As we then play through Friday, the front clears. We get into Saturday. Now remember, on Saturday, it's Sunday, the ridge builds in, the high over low sets up. So there's an upper level low here. And what we're going to watch is where that upper level low goes on Sunday into Monday. See it? And there's a weak low that moves over the Hudson Bay that leaves up front. And what we could be seeing here is Monday into Tuesday of next week. Rain in through this area. Not a lot, but some rain. And the upper level low leaves, possibly on its way, delivering some moisture to Kansas, Oklahoma, Texas, which doesn't need another drop, especially in eastern Texas, and then gets into the southeast again. I like the European solution on this. Now, once we get past this, does the pattern begin to just open up into this corridor? I would like to show you now, these are the operational runs, and I'm just going to let you know my eyes are over here right now. When I look at this next Wednesday, Thursday time frame, both models are trying to put some deeper low. So this upper level low, because it's under a big high, it's going to take most of next week to move. But it could be here by the time we get into next Friday. Now, what's the issue? We need to open up some planting windows in our central and eastern Corn Belt. I think they're going to open up in the western Corn Belt first. But this is going to be the area that kind of sees the wettest weather longest. And that's mid-month. There's a lot of places in here that if you find an open window somewhere in the next 7-8 days, go after it, because it's going to close up again, it looks like, by next Friday. So given all of that, I thought it would be neat to show you this map. This is going to be a part of my new map modeling suite, which I hope to release to you by the end of this month. I'm working hard on it. But this is day 4 through 7. The map will look a little bit better when I finally put it in the new forecasting system I've got. But what I want to show you, so day 4 through 10. So this doesn't include the exit of the first system, but gets the next few. This is the area that keeps showing up with a better chance of getting a window. But with that last low, the one that's under the high over low, that's why it's so dry here. As this exits, that's why we see such wet weather here and in the southeast. Okay? But week 2, let's go have a look at it here. There it is. Notice how the CPC has started to back off on moisture here. The European has backed off. And this is the exit of the system I just described to you, that one that's coming next Friday. I'm a little just excited about it because I think we're going to be able to get some sort of window opening up here to get some of this crop in, because we're feeling a bit late. We really slowed down on planting progress in these last 7 to 14 days. All right, let's talk temperatures next. Frost risk. As we mentioned, still cold air in the west, watching very carefully here, but then dotted throughout Utah, parts of Idaho, and then here in this section of the Pacific Northwest, plus the UP, northern Wisconsin, and Maine. Min temperatures, just to see this, that's one spot I'm watching today. That's this morning's lows getting into tomorrow. And then we have this cooler air following this system across a broad part of the country where we have highs that'll be in the 60s, maybe 70s, low 70s. and lows in the 40s. So this is getting into Saturday. That cold air spreads east. These are Sunday morning's lows. Look at the warmth coming in the west. Where's all that warmth coming from? That high over low setup. That's low temperatures. Let's talk about highs. Here's today's highs getting into tomorrow. Major cool down here. Very cool along the front range here, getting out into the high plains. That's the cool air moving east on Friday. Look at the warmth in the west. That's Saturday into Sunday. And then it just returns. A lot of warm air comes back in after this. And there's your day 5 through 10. That's when this cool air finally leaves. Look at the warmth piling into the west. And there's day 10 through 15. We need that warmth in the west because since March 1st, we are very much on the cold side of the distribution of years here in the west, whereas we've been much above average here for most of this time period across parts of the eastern United States. All right, so what do we do with this? We come back to the narrative. The narrative is this. After this week, does high pressure start to want to live here more often? The new outlook from May 16 to June 15th keeps putting it there. And you're saying, well, what's the significance of this? Again, the significance is where the jet stream's going to have to line up over the top of it, how it pushes systems east, and do we start to get a chance at slowing down the moisture and the precipitation here? Because if this high pressure cell still lived north of Hawaii and we built one back into this area, then the flow goes over the top of it here, dives in and rolls like this, and they just don't see it. The models aren't showing it. And that's why the precipitation anomalies from mid-May through mid-June are favoring drier conditions here and wetter conditions east, right? So that's just the consistency in the model. Now, speaking of consistency in the model, I want to show you this. What you're looking at here is the April forecast from the European model for June, July, August. And we've had this discussion about dryness spreading in this area and how it might get into the plains or how it might move to the Corn Belt. But in April, the models were quite stormy south, southeast, and throughout a big section of the Midwest. The newest model run, this is May, so watch the transition, so keep an eye on the map. This is the newest May outlook. And I mentioned this initialization bias that models sometimes have. So this new May update for June, July, August, the maps have always been June, July, August, has now got a much stormier corridor in through here and has trended a bit drier in parts of the southeast up the Appalachian Mountains. It maintained this particular feature, but much different in the midsection of the country. Now, I bring that up because I wanted you to see the transition from last month's forecast for June, July, August to this month's forecast for June, July, August, so you can see what the NMME did. That was last month's forecast for precipitation, June, July, August, precipitation rate anomalies. So wet here, drier in through this area. This was last month. Look at the new one. Last month, new one. I don't see the stronger signals for the wet here anymore. And it really backed off, keeping the dryness back in the Four Corners states. Now, model trend is oftentimes more important than anything else. And I'm just going to make one more statement on this. I still don't think these models know exactly what this summer pattern is going to look like. I think they're very much biased to where we just saw the pattern come from, right? This is why I started with it. Where did we see the drier air coming in? The jet stream dove in like this and then ejected, and all of this stayed stormy. I think that's what they were started with, and they're trying to just see the evolution of that, also knowing that there is a La Nina. Well, let me be careful here. INSO-neutral conditions with cooler water and the return of normal trade winds showing up when they were initialized right now. We still have yet to discover if this is going to go full-blown La Nina. But what I'm watching is this. This water here has been getting warmer. And some of the models want to push it. And I'm going to make this statement again. If we push that warm water here and leave this cool, while all of this stays warm, and La Nina starts to show up, that's exactly what happened in 2020's late spring, early summer. Now, there are other factors about 2020 that were different, but from an ocean temperature perspective only, that's why I'm hung up on that year. Take a look at what's changed. Just over the last 7 days, take note of the warming signal that we've had in this area. And I want to know, is that going to continue to push toward this particular region? Because if it does, these forecasts toss them out the window. What we'd instead see is a lot of heat and drought building in this direction and cascading storms over the top of this. And then an active hurricane season to follow it all up. So just know that that's what I'm watching. Okay, South America quickly as we finish this up. This is the last 30 days through May 7th, looking at precipitation estimated by satellite. The narrative is the same. From Paraguay into this part of northern Argentina and then into Rio Grande do Sul, several places in here picking up 300 to well over 800 millimeters of rainfall. So we have places in here that have got 20 inches of rain. In the last 2 weeks, though, that heavy rain has continued while much of the northern area has dried out. Again, this is about a 2-week early exit on the monsoon. That's what we can roughly say there. Given that things have cleared out, I was just curious if our NDVI imagery would show us something of use. And I picked those areas that have gone over a bit drier over the last 2 weeks to see in a little bit clearer. And the NDVI values are right now about where they were a year ago. Now, NDVI is not the end-all be-all to tell you what the crop conditions look like, but it's something I want to consider. So just wanted to bring you up to speed on that. If we then switch to the current forecast, very cold air is going to be coming through Argentina up to southern Brazil, through Uruguay and into Paraguay, right in through this area. We've got much colder air. This is going to produce a pretty significant frost risk getting pretty far to the north here. But I wanted to show you the latest on the precipitation. So you can kind of just see the maps across the board here. If we just kind of look at the 10-day forecast for precipitation anomalies, this section here of northern Rio Grande do Sul is expecting again to have an excess, I put this back into inches, excess compared to average of 4 inches. And just to the north of it, nothing. Now, one last thing to show you. I mentioned the cold air that's coming in through there. Take a look at how cold it is in Russia right now. A couple of things just to continue to watch and monitor as we go into spring. Okay, that's it. That's all I got for you on Wednesday. We'll talk again tomorrow morning. Thank you.